Oh, really? It's not near.
Okay, let's talk about answers you guys got, and more importantly, how you got the answers so that we can understand how to look at logarithmic things and understand what to do with them or how to calculate them, okay? So log base 3 of 9. Can somebody raise their hand, tell us what the answer is and how they got that? Lindsay?
2.
Okay, and then how did you know it was 2? Good. Okay, so she can look at this right away and know that 3 is the base, 9 is the value of the power. Do I know which exponent to use on 3 and get 9? And she has the answer of 2. Okay. All right, somebody else, part B. Can you tell us what your answer is, how you got it, Paige? Okay, and so how'd you get that? All right, so I'm gauging from you guys, like you can read the logarithm, and from the first two, because they're pretty common powers, we were able to just kind of know what the exponent should be, therefore we could answer the logarithm question, okay? What about part C? Travis?
Negative.
Okay, good. How did you get that?
It's already a fraction. I just think that the negative power.
Good. Okay, so he's using, like, he has really good exponential number sense, okay? And so what that means is he looks at it, he sees 3 and 27 and understands that 3 to the third power is 27. He understands the 3 is not a normal 3, it's a 1/3, so he knows it would have to flip, and he knows his exponent stuff well enough to know a negative exponent makes that happen. So he understands he needs an exponent of 3, so that the 3 gets cubed and makes 27, and he needs it to be negative, so it will flip the fraction over to make 27 instead of 1/27, okay? Did anybody do this differently, but was able to get the -3 answer? They just maybe processed it a little bit differently? Did anybody write anything down on their paper to do the work to figure this out? That wasn't just like knowing the exponent rules.
I just do 1/3 to the x power equals 27, and then I know that to get like basically 3 to the third on the bottom and then over 1/3.
Okay. Good. Okay, so I'm going to write what Grace wrote, and then I'm going to write a couple of extra steps for those of you that struggle with this. So for the people that aren't good with their exponential rules as quick, you guys messed it up. It's your fault. Okay, so the people that aren't as good with their exponential number sense, you don't look at it and be like, oh, it's -3 because I need a negative for this. There is a process that we can walk through, and that process is like, here's what you're trying to think. Then can you rewrite, and this is going to be a really main idea in what we're doing, can we rewrite both sides with the same base? So like 1/3 is really 3 to the -1 power. Is that okay with everybody? So that's like the same thing, just written a different way. And 27 is really 3 to the third power. This part is key, that I made them both have 3 as the base. So I basically have 3 to the -1x equals 3 to the third. So here's the thing. If somebody walks in and says 2 to what power equals 2 to the 5th power? What's the answer? 2 to what power equals 2 to the 5th power? 5. Like, it's not a trick question, right? If it's 2 to what power equals 2 to the 5th power, there's no way those things can be equal because they both have 2 as a base unless the exponents are the same, right? What that means for me here is that if you can get this part to be the same, that forces the exponents to be the same. So my -1x has to be equal to this exponent of 3 here, which means then I get -3. Okay, so just another way to do it if you don't immediately see the exponent rules, because some of them get hard, okay? They can become more difficult. So either we know the exponent rule is really good, we know we need a negative, we know we need a 3, and we figure it out that way. Maybe just looking at this, like I feel like what Grace was saying is she could just look at this and then she understood that she needed a negative and she needed a 3. And then for those of us that don't see that, we need to try and get equal values on the same side as the base so we can like understand what the exponents could be, okay? All right, log base 5 of 1. Somebody else. Lindsay? 0. How'd you know? Good. So it's 5 to what power equals 1, right? And again, if you were using my method, if you're like, Miss Dahl, this other method doesn't work, it technically works because we know that 1 could be 5 to the 0 power. And so then we know the exponent is supposed to be 0, and so we could see that 0. I'm not saying that you have to do it that way every time. I'm saying when you're stuck and it doesn't make sense, think about rewriting it in a different way, okay? All right, what about part E, log base 2 of -4? Yeah, Trina. Good. Okay, there's actually no solution to this because the question you would be asking yourself is 2 to what power equals -4? 4 is the same as 2 squared, okay? But is -4 really a power of 2? Is there any exponent that you can put on a positive number base? So 2 is a positive number. Is there any exponent that's rule says it changes the 2 to a negative? None of them. If you put negative exponents, it doesn't change them to a negative. Negative exponents just make it like fractional, right? 0 exponents, they don't make it negative. 0 exponents makes it 1, okay? Fraction exponents are the same thing as having radicals, if you guys remember that from Algebra 2. No exponents have the power to make something negative. If you had a negative number to start with, sometimes with an exponent it'll be negative, sometimes it'll be positive, okay? But you don't have a negative number here to start, okay? So no way to get that to happen. What about part F, log base 3 of 0? Jake?
Is it undefined?
Good. Also no solution. Just like you can't find a power that makes things equal to negative, there's also not a power that makes things equal to 0. Again, go through all those exponent things. 0 power makes it equal to 1. Negative exponents make a fraction. Fraction exponents make radicals. There's no exponent that has the power to turn something into a 0. Okay? So these things cannot happen. Is that okay with everybody to review kind of some exponent stuff? All right, so our goal in reviewing this is to use our exponent and log knowledge to solve equations. So I'm going to show you both sets and then we're going to work on one instead of the other. So the top 3 are considered exponential equations. Are you guys good with why they're named exponential? Okay. They're named exponential because in the given equation, x is in the exponent that you're being given, right? The bottom equations down here, okay, they're logarithmic. Do you guys see it? It's a little easier to tell if something's a log equation because it literally has the word log inside of it. Okay? Is this all right with everybody? Okay, so we are going to look at the exponential equations first. Okay? And we're going to look at solving these 3 equations. They kind of have different levels of difficulty and a couple of different ideas in them. All right? So, first idea, just like solving square roots, cube roots, quadratics, or cubics, see where your x is in the equation. You want to get x alone. It's hard to get x alone at first because it's trapped in the exponent. Will, are you guys okay over there? Can we leave the paper bag alone? Thanks. Okay. All right, so we have 3 to this exponent minus 5 equals 22. I want x alone, but before I can get x alone, I need to get this whole power that contains x in it alone. Right? So the first thing I'm going to do is add 5 to both sides. So I get 3 to the power of x minus 2 equals 27. So this actually can be solved how it is because 27 is a power of 3. So just like we were just doing those log problems, if we didn't know how to figure them out, we tried to make the same base on both sides. That is going to be the strategy we want to use first. So can I make the base the same on both sides? So on the left side, I have a 3. 3, if you don't want to get into fractions and stuff, 3 is only a power of 3. I can't change it. But 27 can be rewritten as a different power. It can be 27 to the first power, or it could be 3 to the third power. Is that okay with everyone? So I'm going to change the way 27 looks because I want it to have a base of 3 because that matches the base I have on the other side. Okay. So now what this tells me, it's like the little silly question I asked you guys before, 2 to what power equals 2 to the 5th power? And I was like, it's not a trick question, right? It's literally, if they're both 2's, they both have to be the same exponents if they're equal. Same idea here. If these are both 3's, the only way they're going to be equal to each other is if this exponent is the same as this exponent. So I'm not canceling anything out or dividing both sides by anything. I'm just using logic or common sense and saying the only way this can work mathematically is if the x minus 2 is equal to 3. So I'm just taking the exponents out of the equation and making my own smaller equation and saying this is the only way this is going to work. Okay, and if that's the only way that it works, then x comes out equaling 5. Okay? Is this okay with everybody, this idea? If I wanted to check my answer of x equals 5, what would I do? plug it back in, right? And just make sure that it works. Now, do you have to check an answer? So the good math student answer to that is that we always check our answers, right? But if I wasn't being a good math student, if I knew I never made algebraic errors, okay, which doesn't happen for anyone, my answer should be right, okay, because exponents don't have any limitations. You can put anything into an exponent. So plugging 5 in there is not going to make anything not work in this equation. But if we want to be good math students, we would plug 5 in just to check that it works the way it's supposed to, and then it comes out to equal 22 or whatever it was supposed to equal at the beginning, okay? All right, let's try to do the same thing with part B. So we have 4 to the power of x equals 5. So your first strategy is what we just did in part A. Can I rewrite it so that they're both using the same base so I can just not worry about the base and set the exponents equal to each other? Okay? And the answer to that is no, right? 5 can only be written as 5. It's not a power of anything else. 4 can be written as a power of 4 or a power of 2. Okay? Those aren't the same. So what did you guys learn in Algebra 2? How then can you approach this problem? McKenna? Okay. Good. So basically we're going to use logarithms. So here's the thing. You know how like if an equation, side note, I know, I'm sorry, but like let's say it's like this, and you know there's multiplication between 3 and x, but you don't know 3 times what equals 22. So you try to get rid of the 3, and what do you do in this equation to get rid of the 3, this little equation, if this is multiplication here? What do? You divide by 3. Is that okay with everybody? And then like, oh wow, the answer is 22 over 3. The reason you use division is because x was involved in an operation of multiplication, and division is the inverse operation of multiplication, right? Inverses undo each other. Logarithms and exponents are inverses. So if you have an exponent equation that you can't solve just the way it is, you need to undo the exponents, and the only thing that undoes the exponents would be the inverse of exponents, which are logarithms, okay? And there's kind of 2 ways that you guys can write this depending on what your teacher showed you or what you liked best. So one way that McKenna is talking about is we're literally just going to rewrite this in the log form. And if you struggle with this, here's my advice to you. If I was a student that always messed up the log form, I would write at the top of my paper something I know and what that looks like in log form, so I can see where all the pieces go. This means the base is the base, the exponent is the answer to the log problem, and the value of the power shows up inside the log, right? So then I look at this and I'm like, okay, I'm going to rewrite this as a logarithm because I can't solve it the way it is as an exponent problem. So I'm going to write the word log. So is everybody okay with why I'm choosing to use logs? I can't solve it any other way. I can't solve it the way I did part A. So then I'm forced to use log, so I write down log. What's the base that goes with this logarithm based on the exponential form? 4. So 4 is the base, so it's the base of the log. What else goes in the logarithm? Right, and if you don't know, you look back right here, right? The number inside the logarithm was the answer to the exponential part. So this would be 5. And then the exponent goes on the other side of the logarithmic equation, equals x. You're technically done at this point. You just solved for x. X is by itself, right? What is x equal to? Log base 4 of 5. Okay, that's it. Right? How many people remember using this method from Algebra 2? Okay. How many people know you use logs, but this is not quite the way that you did it? How many people just don't remember logarithms? No, just kidding. Fair enough. Okay. So there was another method. I will show it to you once so that you guys can see. Sometimes instead of doing that, you know how with equations we like do the same thing to both sides of the equations? So some people think about this as taking the log of both sides of the equation. So they think of it as I'm going to take the log of this side, as that's okay as long as I also take the log of the other side. How many people have seen this kind of method before? Okay, so the way that this works is logs had a certain property that you could rewrite. If there's an exponent inside of a logarithm, that gets rewritten this way. And then to get x alone, you would just divide by the logarithm of 4. Okay, and so your answer here would be that x is equal to log of 5 divided by log of 4. Okay, I'm going to say a couple things about this, but first thing is when I say log of 5 divided by log of 4, logarithms don't exist without a base, right? Just like how could you calculate an exponent if you didn't have a base? So logarithms need a base too. I didn't write one when I was doing this little problem right here. What is the base when I don't write it? 10, okay? Our common whole number system base is 10, so we assume it's 10 if we don't write it. So just don't forget that it's there, it's just not written. Is that okay with everybody? Right? How many people feel like they've seen this second method before? I know I asked previously, but now that we saw it all done out. Okay, either one is fine. And you might look at these two answers and be like, you just got two different answers, but I didn't. There's a change of base formula that says this is really the same thing as this, just written in a different way. And I'm fine with you writing it either way. Okay? Is that all right with everybody? So you can use either method that you're comfortable with. Okay? All right, so part C. Okay. Same type of idea. You look at it, it's an exponent problem. You need to get x out of the exponent. Your first thought should be, can I write both sides with the same base? So I have a 5 on one side and an 823 on the other side. 5 is only a power of 5, so my only hope is if 823 is a power of 5. That's not going to work for us, right? So what am I going to do? Write it in log form. And that can look two different ways for you guys, right? You are either, way number 1, literally just rewriting the exponential form into a log form, or way number 2, taking the log of both sides. Either way is fine, okay? So I'm going to, again, do both of them so you guys could see. If I rewrite it in log form, my base is 5. 823 is the number that would be inside the logarithm, and the exponent was 3x, so it would be there. If you guys do it as the log of both sides, you would have the log of 5 to the 3x power equals the log of 823. And this one just requires more written steps, right? I feel like the first method is less written steps, but requires you to know the logarithm formula a lot better, like how it relates to exponents. The second one is more writing down, but doesn't require you to know that formula as well. So in the second one, since it requires more steps, I'm going to start there. Remember, the whole purpose is that that exponent can be written in front of the logarithm, like it's multiplying the logarithm. Okay. And in both of these, at this point, x is really close to being alone, but it's not quite alone. All right. On the left side, if I'm working with this method, what do I need to do to finish solving for x? Divide by 3. All that's stopping it is the 3 that's there. I need to divide both sides by 3. That would look like this and like this. Okay, and it's perfectly okay for you to leave your answer like this. So it's log base 5 of 823, all divided by 3. What about on the right side? X is there as well. How is x going to get alone in this right side here? If I want x to be alone, what operations are going to make that happen? Jake? Okay, good. So I could divide by just the log 5 first, like we did in the last one. And so I would have 3x equals log of 823 over log of 5. And then what do I have to do to get the x alone? Divide by 3. Now, if you guys don't like thinking of it as divide by 3, because look how complicated this side is, what's another way that I can write dividing by 3 that might work out a little bit nicer here as far as how it looks? Yeah, timesing by 1/3 is the same thing. The only reason I mention that is it might make more sense to you this way when you look at it, that the 3 is just going to join that denominator. And again, these are the same thing. The change of base formula says log base 5 of 823 is the same as log of 823 over log of 5, and then you have a dividing by 3 in this one and a dividing by 3 in this one. Okay, so they are the same. Is this okay with how to approach exponential problems? So I didn't go through all of them, so the main concepts here are the first thing you're going to do if you look at part A, get the exponent alone if it's not already alone. And then you have two options. Option 1, can you rewrite them with the same base? If you can, that's the simplest way to go and will save you lots of time and calculations. If not, option 2 is to use logarithms. Is that okay? All right. So now we're going to look at solving log equations. What if your equation already starts with a logarithm in it? How do you get x out of the logarithm and finish solving it that way? Okay, so we're going to look at these three. All right, so notice here in each of these problems, x is in the logarithm. Okay, if it wasn't in the logarithm, we wouldn't care. So a number's written with a log, whatever, it's not pretty, but it's fine. Here the problem is, how do you get x alone? And I just want to point out to you guys, here is something you cannot do. Do not write this down, but look at what I'm about to do. Okay, this cannot happen, all right? Let's say it wasn't log base 9 for a minute. Let's say it was what we were looking at. Let's say I had like log of x equals 5, and you told me when I don't write a base, what's really my base? 10. Lots of people do this. This is not right, okay? If you take out your calculator right now and you type in 5 divided by log and press enter, do you know what your calculator will tell you? Error, because after it types log, it usually even types a parentheses because your log needs to have a base and it needs to have something you're taking the logarithm of. Log is not a number by itself. Okay, it's something that tells you something about these numbers or relationship, but it's not a value. So do not divide by log, okay? So if you know that you've done that in the past, try to make a note not to do that. Okay, so how do we get rid of logarithm, that word in our equation, if we can't divide by a logarithm? Because we need x not in the log. Josh? Good, we can write it exponentially. So these are interchangeable, right? If I have exponents and I don't want x in the exponent anymore, I can rewrite it with logs. If I have logs and I don't want x in the logarithm anymore, I can rewrite it as exponents, okay? So when you guys look at part A, log base 9 of x equals 3 over 2, which part of that is the base of your exponential expression? 9. So 9 is the base. Which part is the exponent? 3 over 2. The answer to the logarithm is the exponent, right? So 3 over 2 is the exponent. And then the other side of the equation, the value of the power is x. So we've actually done all the solving stuff, but we do need to calculate this if possible. And in this case, it is possible. So here's a little reminder about what these exponents mean, okay? This is like 9 to the 1/2 power, also with a cube. I'm writing it like that so you guys can understand that I'm doing 2 steps, not 1 with that exponent. That exponent has 2 parts, the denominator part of it and the numerator part of it, and they do different things, okay? 9 to the 1/2. Do you guys remember what a fraction exponent means from Algebra 2? It really means radical. So 9 to the 1/2 is the same as having a 9 underneath a radical, and the index is just 2 here, which means I don't even have to write it. It's a square root of 9, right? So this is really the square root of 9 being cubed. What is the square root of 9? 3. So this is 3 being cubed, which is 27. Now, in these log equations, I want you guys to make a big note to check your answers. Not just because I want you to be good math students. You could literally do everything right and get an answer that's wrong with logarithms, because logs have certain things that can't be calculated. When you guys just did the examples up on the board that we did, which logarithms could you not calculate? If you tried to take logarithm of what? A negative or 0. Those were the 2 you couldn't calculate. So the big thing is, when you plug your answer back in, it cannot make inside of the logarithm a negative or a 0. That doesn't mean you can't get a negative or a 0 as your answer. It just means if you put that answer back in, it cannot make 0 or a negative in a log. So is 27 an okay answer? Yes, I put it back in and my problem says log of 27. I don't even know if it's right, but I know that it's not like extraneous. I didn't make a false solution, okay? So we're now gonna move on to part B. We checked our answer, so we're good with it. Part B, same idea, okay? Notice where the logarithm is, right here. That's all part of the logarithm. Everything else needs to be eliminated before I can deal with the logarithm. I need to get it by itself so it looks more like the problem in part A. So basically, any log problem, you want it to look like part A, and then you can move forward and go from there. Okay, so I'm gonna go ahead and add 6. And then do what? What do we need to do now? divide by 2. Are you guys okay with that? I'm just working on getting the log part alone. All right, now tell me what's going to happen next. Somebody tell me what I can do with this. I see. Danielle. Good. Change it into exponential form because we can't do anything else here. So what's our base for our exponential form? 6. What's our exponent? 4. And that's going to be set equal to everything inside the logarithm, which is x plus 1. Okay. So 6 to the 4th power is a little bit big. I happen to know 6 to the 3rd power is 216. If it was a test and this was like, you're like, I don't even know any of those, you could leave it like that. So 1296. Is that okay with everybody? All right, and then I just have to still get x alone, so I need to subtract 1. So x is equal to 1295. And then you need to check that that doesn't make a negative or a 0 inside your log. Is 1,295 fine to plug back into the original problem? Yeah, okay. So we're fine, and we just leave it with this. All right. Okay, last one, and then you guys are set. And then tomorrow we're just going to practice this so that we can prepare for our quiz. And after we do this one, we'll check 2 problems on your weekly review because you should be able to do them now that we reviewed logs. All right, so last one. Do I need to move anything before I start looking at the log? No. Okay, it's kind of set up like A. It doesn't look like A because it's more complicated, but it has the log on one side and whatever. So our strategy was then to rewrite it in exponential form. Okay, so what's the base? 5. What's the exponent? 2. And then on the other side goes everything in the log. So we get 25 equals x squared minus 144. Now this is a quadratic. If it was a more difficult quadratic, like let's say the 144 had an x with it, I would get everything on one side, set it equal to 0, and have to factor or use the quadratic formula like you guys have practiced in your weekly review. Because all the x's are right here in a squared, this is kind of like the quadratics in vertex form, right? They already have the perfect square right here. I just need to take square roots if I can get that x alone. So I'm going to choose this time to move the 144 over here because I'll just have x squared equal to 169. Is that okay with everybody? Why I made that choice and I didn't have to like factor or do anything else crazy. It had all the x's in the x squared, no other x's in the problem, so I could do it a little simpler. And then I would take the square root. So luckily 169 is a perfect square. Okay. And that gives me positive or negative 13. Okay. Because I square rooted both sides. So if something squared is supposed to work out to be that, it could be positive 13 or it could be negative 13. Okay. Now I need to check my answers. When I plug positive 13 in here, I would square it and then subtract 144. So 13 squared is 169 minus 144 is positive 25. Is it okay if I put positive 13 back into the logarithm? Yes. So that's a good answer. What about negative 13? So negative 13 squared is 169 minus 144 is still positive 25. So even though the answer was negative, 13 and negative 13 both work because of what it looked like when I plugged it back in. Is that okay with everyone? But do we understand the emphasis to check? I know that here none of them ended up not working. If something didn't work, we would exclude it as a solution. So in this one right here, let's say negative 13 didn't work, then you just wouldn't write negative 13 and your only solution would be 13. In this one, if 1295 didn't work and I had to exclude that solution, then my answer would be no solution because I have nothing left to solve that problem. Is that okay with everyone? Yes. All right, so that's basically it. And tomorrow we're going to be practicing this with our homework, doing it in class, trying to perfect it. Our quiz this week can include anything from the weekly review, okay, as well as this stuff that we're working on, so solving the log and exponentials. It wouldn't have any graphing log and exponential problems. We haven't done any of that yet. We're not going to look at that till Friday, okay?